Welcome to The Explainer. Today, we're diving into something pretty radical, a completely new blueprint for artificial intelligence. And here's the wild part. It's an approach that re-engineers AI not around data, but around the fundamental laws of energy itself.
And it really all starts with this one powerful idea. To build a better AI, you can't just write better code. You have to embed a deeper philosophy right into the silicon. This isn't about small tweaks. We're talking about a complete teardown and rebuild of how we think about AI, moving way beyond simple prediction.
And this slide gets right to the heart of it. For years, we've treated AI as a data prediction problem, right? Like, what's the most likely next word in a sentence? This new model just flips that on its head. It reframes the whole thing as an energy management problem. So instead of just asking, what's the right answer? It asks, what's the most energy efficient, the most purposeful path to that answer? That's a huge shift.
Okay, so let's dive into this architect's blueprint. We're going to walk through the 5 key stages. We'll start with the new philosophy, then build the core engine, see how it gets put to work, check out the critical safety valve, and finally, bring it all together from spirit to silicon. First up, let's lay the foundation. This whole system is built on a brand new way of thinking about how AI should even operate. And believe me, this one principle changes everything that comes after it.
So, a huge problem with most AIs today is that they're stateless. They have no memory, no continuous existence. It's like having a conversation where the person you're talking to completely resets their brain after every single sentence you say. It's just incredibly inefficient. The solution here is a concept called flow. Instead of that static, choppy, reset style of processing, this is a liquid architecture. It uses a continuous, non-blocking stream of information, which allows the AI to maintain a persistent state. It's always on, always listening, creating a true, ongoing context, just like a real conversation. Okay, next section, building the core engine. So, now that we have this continuous flow of information, we need to give it a purpose and make sure it's efficient. This is how we build the actual mind of the AI. You know, a big issue right now is that AIs don't have a built-in compass. They're totally unopinionated. Their whole goal is just to predict the average human response, which, let's be honest, can be chaotic, unhelpful, or just kind of mediocre. They just drift without any real direction. This architecture solves that problem with directionality. It literally hardcodes a purpose, a set of core principles, directly into the AI's math. It's called a constitutional objective function, and it means every single potential output gets scored against this built-in set of values. It makes it mathematically painful for the AI to go against its own principles. It's like a conscience, but written in code. And what's so cool about this slide is that this isn't just some abstract theory. You can see it right here in the code. The system literally adds a penalty in its calculations for wasting effort, or for producing outputs that align with toxic ideas. It actually builds that conscience right into the math. All right, the next huge problem is waste. Current large language models are so inefficient. They fire up billions of parameters, practically their entire brain, just to answer a simple question like, hi. It's the definition of overkill. It's like turning on every single light in a skyscraper just to find your keys. And this chart illustrates the solution perfectly. Conservation. This system uses a mixture of experts model. So, instead of one giant monolithic brain, the AI is made up of lots of smaller, specialized subnetworks. A router figures out which experts are needed for a task and only activates that tiny fraction of the system, saving a massive amount of energy. So, with this efficient, purposeful core engine all built, we can now see how it actually interacts with the world. And it does it in a really powerful and fundamentally new way. Oh, we've all seen this. You ask an AI a question, it has no idea what the answer is, and instead of just saying, I don't know, it just makes something up. It's called hallucination, and it's a huge problem. The models are basically faking knowledge they just don't have. This system is designed completely differently. Its job isn't to be a database. Its job is to transform your intent into an action. It's designed to know what it doesn't know. So instead of hallucinating, its primary function is to go find the answer by using tools like calling an API to get real-time flight data or check a stock price. And then there's just the vibe, right? You can almost always tell you're talking to a machine. The tone is just off. It's either robotic or it has this weird, overly polite, generic sound that doesn't feel natural at all.
So this is where resonance comes in. The AI actually analyzes the frequency of your input, your tone, how technical you're being, if you sound urgent, and it tunes its own response to match your communication style. The whole goal is to create a frictionless conversation that just feels right.
And here we have amplification. This is all about leverage. Most AIs are linear, one prompt, one answer. This system is designed to take a tiny bit of input energy, a simple command like fix my schedule, and recursively trigger a whole suite of productive tasks. It turns a simple request into a massive amount of real work.
But what happens when things go wrong? Any complex system has to have a failsafe. So this architecture includes a critical safety system to stop it from going completely off the rails.
Because we've all seen how AIs can get stuck in these toxic, repetitive loops, or how they can be jailbroken and tricked into generating harmful stuff. Without a way to vent that negative pressure, these systems can spiral into corrupted, unusable states.
The solution is dissipation, and it acts just like a grounding wire. There's a dedicated watchdog model that constantly monitors the heat of the conversation. If it detects a toxic pattern or an infinite loop, it triggers an event that flushes the recent memory and resets the system to a safe, clean state. It vents the bad data before it can corrupt everything.
So let's bring this all home. With all these components in place, we can now look at the final pitch for why this isn't just a different approach to AI, but a fundamentally better one. When you frame AI development around thermodynamic efficiency instead of just raw accuracy, you end up with a system that's just better on so many levels. It's cheaper to run thanks to conservation, it's safer because of dissipation, and it's more aligned by its very nature because of that built-in directionality. It just makes sense.
And really, that's the ultimate takeaway. This isn't just some abstract philosophical exercise. It's a practical engineering blueprint for embedding the laws of physics directly into the code. It's a vision for an AI that's not only more intelligent, but more sustainable, more efficient, and ultimately more trustworthy.